Welcome guys. So myself Dr. Ketan Desale. Today we have a very prominent guest with us, Dr. Nilanjan Dey. So we'll have a podcast on AI in healthcare as one of the prominent subject. So I will have a quick introduction about Dr. Dey. Sir has completed his PhD from Jadavpur University, currently working as an associate professor in Techno International New Town University, Kolkata. Also, he is a visiting fellow at University of Reading, UK. So, with very versatile research background, he's working in the domain of artificial intelligence and deep learning and machine learning and biomedical related thing. So, in our coming part, we will discuss on specifically on application of AI, challenges, and then the future scope of AI in healthcare domain. So, to start with, Dr. Dey, first I welcome you on behalf of our community radio and Pimpri Chinchwad College of Engineering. So can you please just brief about you and what motivates you to work in this specific domain?
Yeah, I did my PhD from Jadavpur University in 2015, and before that actually I was in research, teaching. Then I was in academics for last 16 years. So then after that I joined Techno International New Town. Currently my working current institute. I did after PhD I was associated with University of Reading as a visiting fellow, and apart from these there are many other countries also in which I am currently working as an adjunct or visiting professor. In research area, my interest is biomedical imaging and how to deploy the AI and so-called machine learning techniques into CAD system, means computer-aided diagnostic system. So in this area, mostly we are focusing and we are working in disease diagnosis and detection, etc. These parts.
So how it starts means like you should work on.
It started during my masters. So there was a teacher who actually was our teacher of digital image processing. So he was good in coding also. So he used to ask us to explore different areas of imaging, and we started exploring different applications area. But medical imaging, I think it was a very interesting area where the images are mostly dark images, perturbated images, noisy images. So those low quality image processing and which will actually ultimately help a big community. There is a societal part also. So for that reason, maybe initially I was more indulged into medical imaging. That later in medical imaging, for different disease diagnosis detection, our team deployed AI, how it is intervening the diagnostic process and detection process, etc.
Yeah. If you think AI is also a very booming domain, as well as healthcare domain is also very booming. How you think AI, how it is transforming the healthcare domain is?
In India, per patient means one doctor equals to patient ratio. It's 1:837, I think. So 830:1. That's a big challenging number. Second thing is per patient in India. There was a report in Times of India. Where it was reported that per patient in states, a patient used to get 21 minutes from doctor, but in India it's 2.3 minutes, and in other countries like Bangladesh 48 seconds. So there is a high chance of human biasness, medical errors, because doctors are also human being. So from error point of view, the number of medical errors is huge. India per year there are almost 5 million medical errors. I'm not talking about medical negligence. I'm talking about only medical errors. Yes. There can be surgical error, there can be some diagnostic error, but majorly diagnostic error. So diagnostic error can be reduced by AI. Another thing is the detection. There are some disease which might not be killed but can be healed. So if you go for early detection, like say for example in glaucoma, which is silent killer kind of disease. So if you have early detection technique mechanism, strong technique, might be it would be good for many people where you can early detect or you can predict the breast cancer early stage. Like few weeks back there was a report that before 6 years the researcher had tried to actually they come up with some predictive model that there might be a chance of cancer growth in breast cancer. So this is a very good thing. So I think AI can revolutionize these things, means the detection, diagnostic, the visualization part, maybe the storage part, etc.
Right. As it is like AI is having multiple applications, like it could be deep learning, it could be natural language processing, it could be machine learning. So what is prominently more effective in a healthcare domain specifically?
Yeah,
or altogether all are...
Before 2012 it was a shallow machine learning,
Yeah.
traditional machine learning. But after 2012, once AlexNet introduced, there was a sudden paradigm shift. So deep CAD system comes, and there was a huge speed and rapid diagnostic process, and faster diagnostic process, which is very much required. So deep learning actually is a kind of paradigm shift. But apart from this, in last couple of years, many researchers are working in LLMs. So LLMs also have very impact in medical diagnostic point of view also. So it's not foolproof, but still it is giving a rough sketch. So I think down the line, maybe this kind of support, means from LLM, maybe core NLP, maybe machine learning, which will be very helpful for this disease diagnosis detection process.
Right. As you're one of the core area like medical image diagnosis, so how you think AI is morely focused on the accuracy point of view or the speed point of view?
Accuracy, speed is always required, means faster diagnosis is always important, because if I'm talking about a disease and the detection takes a lot of time, it's always not acceptable.
Right.
But accuracy point of view, accuracy is something, if the accuracy is coming good, but there is an issue of trust, means why should I trust this particular issue? There is a big issue. So that's why the next phase might be explainable AI, which is a kind of, you can say, make the models more transferable, interpretable. So that is the next phase, means it's not only about the model design, rather it's better to talk about the explainability of the model, so that the acceptability of those results can be you can be enhanced. So I think XAI plays a significant role. So once we talk about responsible AI, so for disease diagnosis detection, not only accuracy, how you are getting accuracy, that black box need to be open, so that it will be more trustable to the patient, to the doctors, etc.
Right.
So
correct. And when we implement it actually, so there are two sides of the system. Like one is the implementers, like engineers, those who are specifically work on a technology. On other side, there are professional, medical professional. So how you think how they should collaborate and work together?
See, as an engineer, we don't have that much of expertise in medical domain, and the doctors don't have time. Firstly, they are too busy, and even though they have time, maybe they are not technologically that much aware, or that much, they are accustomed with those systems. So there is a gap in between this. So few days back, I was in a workshop, rather better to say in a particular, I was actually addressing some doctors, and I found that there is a gap in between the doctors and what we are trying to propose. See, CAD system is designing, means it's a kind of supporting system to the doctors. It's like giving a support system, supporting hand to the doctor, so that as a human being, if they are making any mistake, they can cross-validate what they are proposing.
Right.
Its intention is not to substitute the doctor, rather to help the doctor to come up with a faster diagnosis, maybe a correct result, more accurate result. So that's why I think CAD should be more and more research should be there in CAD designing, and it needs to be acceptable to the doctors, the patient, in all different stakeholders.
Yes, as every technology has its very good strengths, but obviously it comes with some of its drawbacks as well. So what do you think? What are the challenges in implementing AI in healthcare?
AI healthcare, there are a lot of challenges. Like one is any particular algorithm, machine learning model, we used to deploy on a particular demographics or ethnic data. Now, if the ethnicity changes, the disease may be different type, maybe the symptom may be different. So the same model might not work. So patient from Africa, patient from Japan, patient from European country, they're different. So one standardized model is very difficult. And there are a lot of issues with data privacy policy, because every country they are coming up with a lot of privacy policies. So getting data is another big challenge. So in medical imaging, one of the major obstacles is getting data. So as much as good data we are able to gather, the model might be more and more robust. So there are a lot of actually issue related with the data, because it's
Right.
all dependent. It's a kind of, you can say machine learning models are mainly hungriness of data.
Right.
So you have to feed more and more clean data. So that is very
And how
important.
geographical locations do affect on our models?
It's affect a lot, because see, food culture, the smoking pattern, the alcoholic nature, the sleeping pattern, all these different for many different countries. So if you are considering one particular data set from a particular geographical a place, so say for one particular region we are testing, that model might not work for other place. So to come up with a very generic framework, it's very difficult, and you need to gather more and more data from different places, different demographics. So that is very important. So it should not be biased. So biasness is very crucial, because if it's a bias, it will not work.
Right. So all sort of possibilities.
Yeah,
will
possibilities
cover.
are there, but there are a lot of different other challenges also. Like quality of the image is a big issue. Majorly, you not get the diacount data. It's a very low quality data, and processing low quality data is something very difficult task.
Right.
Another thing is the ground truth, the benchmark data. We received very less because doctors don't have time to benchmark, so we can't compare the data. So we need to, rely on the weekly supervised learning technique, etc. So this is another challenge. So even small data is a big issue, because if the data size is small, once we talk about big data, there are this sounds good, but once you talk about small size data and processing machine learning algorithms to come up with an explainability model with small size data is really different altogether.
Right. Sir, many of our listeners are either students or they are young researchers, and as it is a buzzword like AI, LLM, and healthcare domain. So how do you suggest them how they start their research journey in this specific
I think it will be a good approach. You take a public data set with a good number of data, and there should be proper benchmark, so-called well-established data. So many researchers work on that particular data. Maybe one particular modality, maybe one particular disease. Then try to check all the different models which are already deployed, and see what are the different limitations are there. Then after that, maybe you try to find out, okay, there is some place where I can contribute. So in that way, it can be a good start. Means, see, the interesting part of medical image or imaging is any single line change you can see. So you can visualize. So any line, if you write, you can see the effect change. So I think that will actually make much more attractive for all people to do research in imaging, because once you do image, something change, actually you can visualize immediately.
Right.
So this way they can start.
Right. Considering the complete trend or complete research in this particular domain till date, next 5-10 years, how you look after this, how it will impact?
Yeah, people are trying to do more and more CAD system now. See, we need to gather doctors' faith that they should use it, and they should actually give their feedback to those engineers who are working in CAD system designing. And the patient should must rely on this CAD system, doctors and the CAD system both. So trust issue need to be built up, and down the line, all these machine learning algorithms, we should not chase only the accuracy. We should try to find out that how good these models are, means from interpretability point of view. Because if we try to come up with a white box, then trust issue can be built up easily. So then only this accuracy, these numbers will be more trustable numbers. So not only the numbers, but I think the most important thing is down the line in next years that we should try to convince people to use it, and also try to come up with a more and more trustable system, CAD system, so that it is easier for us also to convince them.
Right. And do you think that interdisciplinary collaborative work will
it's
definitely
very important, because see, major problem is somebody know deep learning, someone know imaging, someone
domain expert,
maybe bioinformatics, somebody is working in chemical engineering, someone chemical domain, maybe different areas. So maybe in mechanics also, fluid mechanics, someone is working in fluid mechanics. So many places, many different disease detection requires different domain expertise. So not only a computer guy, it's not a task of a computer. Maybe different area, different engineers, they can actually come up with more rational, good, robust system making of CAD system design.
Nice. So, at the last, we just want to know, sir, ki currently on what recent topics or what recent problems you are working on, or your students and you are
See, in recent time, I am working. Some of our work group is people are working. Co-researchers are working in plankton imaging. So it's a kind of sensor capture data fit, and they try to come up with designing something one part. Some people are working. Some researchers who are working into the area of DNA work study. And some people and traditional those retinal images.
Right.
Some students are working especially in the retinal images, glaucoma detection, portable system designing, low cost system designing, because where detection is very important, early detection. So there are a lot of different group. 4, 5, 6 groups are there. Someone is working in detection, someone is diagnosing, someone is storage.
More
also.
focus, I think, is on early kind of
early
detection, like biomarkers or something also.
Because if you detect early, then maybe it's very good way to prevent it. So that is the way.
Thank you, sir. So altogether, I think so. To summarize, we could focus on the AI's impact on the healthcare domain. Then what are the recent things which is going on in this respective domain, then challenges, then followed by the future perspective ki where actually the current researchers or young researchers are working on, along with the trust or that is the main factor. So with this I once again thank you, sir. Thank you for joining us and coming.
Thank you very much.
Thank you.